not sure. We usually pack this room.
It's a holiday, isn't it?
Yeah. Holiday?
Yeah.
No, it's a, oh, sorry. I'm Michael Wheeler. I run the Ethereum Enthusiast Meetup. Been doing it for 2 years now. It's been a great ride. Just got back from Shanghai at the DEF CON 2 conference. And there's been a lot going on. I just put up here, you'll notice a lot of red here. This is the live Ethereum network. I'll come back and kind of explain this if you haven't seen this before. But I thought it made sense to maybe talk a little bit about infrastructure underneath the Ethereum network for this meetup. So, my background, I spent 11 years at Bank of America working in infrastructure, so I have like a deep technology infrastructure background in financial services. Ran a lot of trading platforms for equities, fixed income, back office risk, etc. So now I'm kind of focusing on infrastructure in the Ethereum space. So I thought I would just talk about reliable Ethereum infrastructure. As we know, like the Ethereum network has only been up for like a little over a year at this point. It's all kind of fledgling ecosystem built from the ground up, so there's been a lot of challenges. If you look at like the centralized concept of the internet, this is what people think about, right? So everyone here has participated on the internet, and traffic is going in through all of these big players and coming out. So if I'm this person and I want to talk to this person, chances are my traffic's going through one of these big service providers, also your Time Warners, your Verizons, etc. So the idea of decentralized is this, right? So let's get rid of that and let's just let all of these people talk to each other. So everyone can just talk straight to each other. We don't have to have these people in the middle making decisions about what we can and can't say to each other. But that's not quite right. So what do we actually have to have for that to work? It actually needs to look a little more like this. So for each of these edge nodes to be able to talk without each other, they need an Ethereum node. So you need to run the Ethereum software to connect to the blockchain and participate back and forth. So what that does is that presents a little bit of a challenge where it's kind of hard to run an Ethereum node on an iPhone right now. And it's kind of hard to run an Ethereum node on any computer right now. It's difficult to keep up with. So there's this notion from the Ethereum Foundation website. Build unstoppable applications. It's a pretty lofty claim, and it's actually false. And in fact, at DEF CON, Alex Van de Sande, who wrote this, kind of even acknowledged that. You see if you watch one of the videos. It's kind of it's the concept of a blockchain being unstoppable, I guess, theoretically is there, but in reality, it is quite easy to stop an application. You got a question? Okay. So what would you do to do that? If you just attack these nodes at the edges, it prevents all of these other nodes from interacting or from reliably interacting. So what I showed at the beginning, let me talk about the last few weeks. So, does anyone speak German in the room? So what is this? What does this mean?
Ride home.
Go home?
Yeah.
Right on. Yeah. So on October 19th, it was actually October 19th, early morning in Shanghai. There was a transaction that got injected into the Ethereum blockchain. It was about 4 in the morning in Shanghai. This was the morning of DEF CON, Monday morning. DEF CON was supposed to start at 9 in the morning, the big celebration of the Ethereum world. And an attacker submitted a transaction. This is the transaction hash. You can look it up. And in the body of the transaction, there was this little go home message. So clearly someone was trying to destroyed DEF CON 2 at that point and like really put a damper on it. Fortunately, the developers of the Ethereum client got right on it, and they were able to get things kind of resolved pretty quickly. And DEF CON 2 had a late start of about 30 minutes. But what that did is it kicked off several weeks, which is even ongoing today, of instability in the Ethereum network. I showed this before, I just took a screenshot. So this is what was up before. This is ethstats.net if you haven't seen this before. So what this is, and before it was actually live, it was running, but this is showing you the health of a certain group of participating nodes on the network. So it's not the whole entire Ethereum network, but it's 46 or so nodes that chose to kind of plug in here. This is my node here. As you can see, I'm running Geth, and I'm falling behind. So the best block is that block. That's where the blockchain is, and I'm pretty far behind. So if I have an application that I've written that is communicating to the Ethereum blockchain, and it's using this particular node, my node, on my server, it's been stopped, right? We say it's unstoppable. It's not. It's stopped. So it's sending blocks that are so far behind that you can't reliably be sure that the transactions you're sending are ever going to make it. So we started to see this, all of this red, and what is happening. So started in September 18th with the Go Ethereum client. So that's written in the Go language. They addressed it that morning with a patch titled From Shanghai with Love. So the Ethereum Foundation has a little bit of a sense of humor with their versioning. 6 days later, there was another memory leak or another issue where there's certain transactions that you could compose in a certain way and send them into the Ethereum network. As long as you were paying gas to make it happen, you could essentially cripple any node that's running Geth. So we had the next release, Into the Woods. A couple of days later, another release. What else should we rewrite? Then Come At Me, Bro. Then they started to get cocky with the attackers. So they titled the release Come At Me, Bro. And then October 6th, Dear Diary. Meanwhile, Parity, from this time all the way up until October 7th, the Parity client, which is developed by Ethcore, was fine. And fortunately for that, that's why the Ethereum network was able to kind of survive all this, because most of the nodes started to switch to Parity. But we started to see on the 7th, I think Gavin then acknowledged that he started to see his own issues, and he rewrote a patch. And now, actually, Parity's been patching almost every day for the last few days. I think one came out today as well. The Go Ethereum client, their latest one is called Kool-Aid. I thought it's kind of funny. But they're on 1.4.17. But as you can see, they're still falling behind. So if I go back to my stats. So if you look at Roman's client, Ethereum Java is doing pretty well. But most of these Go Ethereum clients are falling behind, including mine. Parity is doing okay. So I think one of the really cool things about the way that they developed, the way that Vitalik proposed the Ethereum protocol, was to not specify one specific client, which you see kind of in the Bitcoin land. So he had a protocol, and then he allowed anyone to develop a client that complies to that protocol. So what we've got in Ethereum is you've got 8 different clients, right? So they're developed by different people. EtherCamp has their Java one, that's Roman. Many of them are the Ethereum Foundation, but you've also got Ethcore, which developed Parity, which is considered by many one of the most stable, robust, secure ones right now. And then you've got some other ones, JavaScript, Ruby. Haskell is kind of a closed system. Block apps and Consensus have written that one. So it actually is pretty prescient that they've done this, because as I said before, The attacks hit Geth, the Go Ethereum client, and that's about 80% of the network. But fortunately, because we had parity out there, even though the Go Ethereum clients were all kind of falling behind, the Ethereum network was able to kind of chug through because of that. So what can we do to kind of resolve this situation, or how can we kind of help developers and users of the blockchain not have to, fight this fight, constantly be, patching their nodes or worrying whether they're ahead or behind on their network. So there's a project I'm working on that is trying to address that, trying to help that. As I said before, what if Shapeshift was out here on this node and its Ethereum connection got lost? And this actually happened to Shapeshift. So they started to fall behind in their block synchronization, so their trades, any sort of transaction they were trying to send to the network was kind of lagging behind. What if you're in a prediction market out here in Augur and their Ethereum connection falls behind? Well, now you don't know for sure what the truth is, right? So these really are stoppable applications unless we can resolve some of this infrastructure issue and get to the point where these edge nodes become much more stable. I think just remembering that we're only 1 year in this whole ecosystem, I think at some point we'll get there where we'll be able to have a much more stable, robust situation. But for now, we're not. So what can we do? There's a project I'm working on. We call Infura. So Infura is the mission is to provide secure, stable, fault-tolerant, scalable Ethereum and IPFS nodes. So what that means is we provide Ethereum node, IPFS, and then we have this service layer. So think of it like a cloud-based Ethereum solution. So we put a service layer in front, and then underneath, if I look at the hamburger picture that everyone likes to do. So underneath, we can have a bunch of different nodes. Geth, I should have put parity here, but so we can have parity, we can have Geth, we can have any different client. We can have a front end, and then the users and the dApp users can just send their requests in, and our service layer, which they call Ferryman, will smart route, and if we detect that Geth is having an issue, we'll just route traffic to, if I had a parity one, for example. So that's kind of the idea of what Infura is. It's meant to be a base layer of infrastructure that developers can, so when you write your code, this is a sample of what someone might write in their code. If you look at these, a lot of times this will say local host. And what that means is for your connection to the blockchain, that means you're running a blockchain on, you're running Ethereum on the local host. What we provide is a hosted solution for high transactions, so you can develop and not worry about whether your node is up or whether it's synced. Now, what is that? It's a centralized service, right? So that, if you're a purist, a blockchain purist, you're thinking, well, wait a minute. All you've done now is you built this centralized service for routing all traffic in. Haven't you just kind of defeated the whole purpose, right? And that's very fair. But I think we got to remember we still live in a centralized world, even in the blockchain space. This just happened, I read. So blockchain info goes down, 8 million people can't move their Bitcoin around because they're tied up in blockchain. So there's still lots of centralized services that we, at least for the time being, in my belief, have to trust. And so the point originally of Infura was for the Consensus family. So Consensus has tons of different projects that they're building, and why should each one have to bother trying to keep their infrastructure? So we built that. The Consensus folks realized that it was a pretty valuable service. MetaMask, for instance, if you're familiar with that, it's a Chrome extension that lets your browser act like an Ethereum node. And MetaMask is a heavy user of Infura, so anytime you are using MetaMask, your transactions are routing through. We're getting about 18 million transactions a day going through Infura. So, and And the key thing is, so on that morning in Shanghai, like the MetaMask team didn't have to get out of bed and do anything. Like they let the Infura team solve the issue, migrate all the traffic over to Parity, and life went on. So that's what we say. It's kind of our thing. The world's going to be decentralized when every Ethereum, I should say node, is ubiquitous and every person is hosting his own node. So we think that we'll get there someday, but for now, the goal is to kind of provide that gateway and that solution to allow developers and users of dApps to just focus on what they want to do, which is write code and develop code, and not struggle with all of these network attacks. So that's kind of all the presentation I had today. Pretty quick one. I don't have any questions.
Yep.
Is there an easy way to explain why these contracts hit Geth harder than the other nodes when they're all on the same network?
Yeah, so I think it was, I think they've determined it was a language, something particular with the Golang, the language itself, in the way that it handled memory. I'm not a deep developer, but that's what I understand. So it wasn't an issue with the Ethereum protocol itself. It was in this particular case just the way that the Go client had implemented a particular set of code related to gas. So yeah.
How decentralized is Infura itself?
I'm sorry?
How decentralized is Infura itself?
So how decentralized is it?
Is it just one server? I mean, just a collection of servers in the same location, or is it geographically distributed?
So it's running on public cloud infrastructure, so Azure and AWS, and so it's distributed that way. At the moment, it's just in the U.S. There will be intention to build out pods in global regions as well, as the traffic needs. We anticipate that we're just at the very early stages of with a lot of these projects in consensus, for example. So traffic's just going to continue to explode. And so at least within the consensus family, we trust Infura to handle that traffic. I will tell you that we've talked to some other companies, that exchanges, for example, and prediction markets, and they've expressed interest in leveraging Infura just because of the fact that it just solves a huge pain point of having to maintain their own infrastructure.
So two kind of related questions. How sophisticated are these attacks? And then if they're not that sophisticated, which is kind of the impression that I'm under, what's to prevent them from replicating this and just targeting everybody at once to stop the whole blockchain?
I think that's what they're trying to do. So I think that initially they attacked the Go client, and they were Go manages managed about 80% of the network, had 80% of the hash rate. So I think they really were trying to just completely take down Ethereum for like a day or 2 or 3 days until they could figure it out. Then they finally got around to figuring out Parity, I guess, later. I wish I knew. I think the related attack, I don't think it's 2 separate groups of people. I think it's one particular group or groups of people that are trying to take down the Ethereum network.
And then how sophisticated are these attacks? I mean, is it something that a malicious actor could replicate fairly easily, or does it take a lot of expertise to develop these?
No, the transactions are clearly, so it's a public blockchain, so we can see the transaction, what it was. If you're willing to pay the gas to execute the transaction, you can do it. So that's kind of the concern. So that's what these patches have been trying to do, is address the gas limit to make it more expensive for these attacks to go on. I think just today, Vitalik proposed they've been talking about a hard fork. Gav proposed it a few days ago, and I think Vitalik confirmed it today. So there's going to be a hard fork to kind of, I think, permanently just put this particular issue to rest, but we'll probably see others. Question?
Yeah, I'm Jacob. I'm the guy who posted the articles on the meetup. Just on the topic of the attacks and also the dependence on Go and stuff, I actually don't know that much about it. I'm still trying to catch up myself, but my understanding is, as you said, they found things which are consume more resources than you'd expect in the different implementations. But the fact that they didn't find something, for instance, that was dramatically slow or impossibly memory consuming across all implementations is kind of reassuring. And also this fact about the hard fork. I mean, my understanding, and I'd love to hear from somebody who has more details, but my understanding is that with Howick and Gavin and these top guys, they have changes that they think would kill off all these attacks. It's just that they seem to really do it properly require the hard fork. So they've been holding off because, of course, nobody wants to just rush out a hard fork if you don't have to. But you know, basically they're kind of on top of it, I think.
Yeah, it's very impressive how quickly they've responded and dealt with the patching of things. Hard fork, unfortunately, due to the whole DAO issue, hard fork is kind of a touchy subject. So I think it's important to distinguish that this hard fork is not a state change hard fork, it's a protocol hard fork. So hopefully less controversial.
And in a way, it's a good time to put out a healthy hard fork that goes well.
Yeah, so there was a hard fork coming anyway for the next release. So some of the discussion is kind of we just wait till then. You know, when they were going to introduce some of the next features, Casper sharding, some of that stuff. Yeah.
So proof of work is still GPU based in Ethereum.
Yeah.
So when you're running Infura and you're running it in Azure, you're leveraging the GPU servers that they have there.
So we're not mining.
Oh,
We're not mining. So we're just running nodes to relay transactions to and from the blockchain.
okay.
Yeah. Yeah, we're not mining at all. Yeah.
How is that
Hey, Chris.
different? What are always trying to get like an overview of IPFS, kind of how like Kira is acting as gateway to IPFS?
Yeah, so I kind of just assumed that everyone knew what IPFS was, I guess. But so if you don't know what IPFS is, so I think of like Ethereum as like the compute, and IPFS is the storage, right? So IPFS is a decentralized storage platform. It's not related to Ethereum, but it kind of gets coupled with Ethereum a lot because it tends to be very popular as the storage mechanism when you're writing decentralized applications. So it's a peer-to-peer based storage solution. So the question was, how does Infura, so all Infura is doing is really presenting an IPFS endpoint, so ipfs.infura.io, and it allows, if you're writing software, it allows you to store data in and out of IPFS. So for instance, Uport uses us for their identity platform, so when you create in your Uport app, you create your picture and your name and your profile, it stores it onto IPFS through the Infura gateway.
Why IPFS opposed to like CM or like storage in? Is it just kind of more sophisticated? Because I haven't really seen like a good comparison at all with the data storage.
Yeah, so those are particular attempts to kind of build like your decentralized Dropbox, I guess. And I think IPFS with Filecoin is going to be doing the same similar thing. At the moment, Infura is a free service. I guess we're not charging, so at some point we may want to look at it. We don't want to be the Dropbox for the internet for free, right? Chris.
So actually going down that line a bit, so let's say like we're 2 years down the line and Infura is routing a ton of the transactions through the network. So I'm trying to think potentially like how this is self-sustaining for Infura as part of Consensus. And then like who specifically would be your customers? Would it be like Augur or let's say Coinbase if they're routing? Like how would that ecosystem look?
Yeah, so exactly. It would be. I actually talked to Joey in Shanghai from Augur about it, and he expressed some interest, for example. And like Etherscan, like blockchain explorers, you know. Those would potentially be the customers. I mean, eventually, you know, we'll see how it plays. It might, you know, for now, our main goal is just to reduce friction in development and enable developers to like focus on writing code and getting it out there and deploy it, so they're not struggling, you know, with their infrastructure. It may very well be at some point that we determine that Infura is really just a stepping stone and it's no longer needed in a few years.
So then, like, if I have a transaction, right, that I want to get through the network, and I'm the customer of potentially one of your customers, right? So I would send that transaction to the service. The service would contact Infura. Infura would route the transaction to a functioning node, which would then relay,
Right.
and then it would be put in the blockchain that way.
Right.
Okay.
Yeah, so it just, so there's the JSON RPC set of commands. So all Infura does is it just basically exposes those commands. So when you write code, you can issue any of those method calls through JSON RPC, and Infura will take it and process it. Eventually, you'll be able to do things like specify which client you want to send it to, what version you want to send it to, in the header of the HTTP request. So. Cool, yeah.
You said that the attackers in this attack had to still have to pay for the gas. Is there any indication of how much money they spent?
That's a great question. I wish I knew. Probably some people know. I would assume that it's a,
One of the articles said, one of the articles claimed that one of the people defending against the attack had estimated that they had spent $5,000 or $10,000 on it, and that was like a week or two ago.
which isn't really that much, to be honest, because you could short Ether, just pay $5,000 and probably make a lot more.
Yeah, they might be making a profit out of that one.
Exactly. Yeah. Yeah.
I have a random question. The original screen you had like they had gas, how much gas being used. Is there a way to see how much gas is being used per day on the community network? Is there any way like a graph of that? See gas spending, how much the gas spending is?
So how much gas went into each of the blocks?
Total for the community network. I think it's going to kind of show like the health of the network, how much ether they
Right.
Is there a way? Is it through the website? Anybody know about that? Or must be.
Yeah, I'm not sure. I would think that even like on a Block Explorer, like EtherScan, they might have something. I'll look that up. Because that's a good point, like that actual usage, actual like activity.
I'm just thinking because I think Alder's going to like explode when that kind of gets up and running.
Right.
Kind of show you what's kind of the health of it.
Right.
I mean, there's the transaction fee on EtherScan, right?
Yeah.
Which is effectively the gas.
That's
each
the gas,
transaction
but
is
does it
spent.
aggregate it? For the, like,
I think you can pull it into like a Excel table,
Yeah.
probably, but I haven't seen it graphically done.
Yeah. Cool. All right, well, if there's no other questions, thank you all for joining. That was a quick one, but appreciate it. Quick announcement too, so we've got a couple more events coming up next week. Chris is actually hosting, there's a very unique event we usually tend to just have presentations here. This one's in an art gallery over in Chelsea. Very interesting artist from Berlin who has a blockchain exhibit. I haven't seen it yet, you have, but it's going to be a great event. Hosted by ARK Invest. There will be beer and wine as well, so that you might want to check it out. There is a hard cap of 75 people, so we do just ask, like, if you RSVP, please make sure you come. If you're not going to come, just change your RSVP so that someone else is able to join. Because we usually just open this up to like 200 people and we get like this many people, right? So, and then there's another one a following week later, and then we'll be back here in November. So, if you have a particular topic or suggestion for November for this venue, reach out to me. I still don't have that discussion topic yet. So, anyway, thank you all.
Thanks, Michael.